Yes, in this session we are going to continue the problem of the previous graph problems. So problem number 2. The speed time graph of the particle moving along the fixed direction is shown below. So this is a speed time graph. So already we are seen in the graph videos itself. So what is the first question? Find the distance traveled by the particle between 0 seconds to 10 seconds. From 0 second to 10 second, what is the distance traveled? So this is the speed, this is the time. So area under the curve represents the distance. So distance is equal to speed by speed into time. So speed into time, which is equal to area. Here you can see that speed into time is the area. The area is a speed into time. So simply the area under this curve, the speed time graph is it is a triangle, half into base into height. So half is a 1 by 2 and the base is a 0 to 10, that is a 10, and the height is a, what is that? 12. It is a 12 meter per second. It is a height. So just to simplify that, we get an answer. 60 meter is the distance traveled by the particle between 0 to 10 seconds. In the same graph, there is another question. So same graph, another question. Average speed between this interval. What is the average speed of the particle between the interval 0 to 10? So the average speed is equal to total distance traveled by time taken. What is the total distance traveled? That is we are calculated 60. So the 60 divided by what is the total time taken? 10 seconds. 60 divided by 10, 6 meter per second. The next question is time when the speed is minimum. The next question is the time when the speed is maximum. So the speed is minimum means this is the speed. So where it is a minimum, this point is a 0 speed. So what is the time? At the time t is equal to 0 and the time t is equal to 10 seconds, the speed is very minimum. And at the time this point, so at this point at t is equal to 5 seconds, the speed is maximum of 12 meter per second. So it is a t is equal to 0 and 10 seconds and t is equal to 5 seconds for maximum speed. So this is a very simple problem. Dear students, just to copy this. Yes, now we are going to see the next problem. Third problem. A body starts from rest, accelerates uniformly along a straight line at the rate of 10 meter per second square for seconds. So the acceleration of the body is 10 meter per second for the time 5 seconds. So after that it moves in 2 seconds with uniform velocity. So after the so it moves 2 seconds with uniform velocity of 50 meter per second. Then it retards uniformly and comes to the rest at 3 seconds. So very simple. For the first 5 seconds acceleration is a 10 meter per second. For the next 2 seconds it is a 50 meter per second. Then within the 3 seconds it comes to. So I think it is not a meter square, it is a meter. So it is a velocity of the body. So first 5 seconds it is a 10 meter per second. Then next 2 seconds it moves with a 50 meter per second. Then it is a 3 seconds it comes to rest. So what will happen? What is that? Draw the graph. Draw the velocity time graph. So at 0 to 5 seconds, what will happen? It increases. So after that what will happen? It moves in 2 seconds uniform velocity 50 meter per second. So just I will draw the 2 seconds uniform velocity. Again it will be decelerated. So 0 to 5 seconds, then 2 seconds means up to 7th second, then remaining 3 seconds means 10th second. So what is the velocity time graph? The velocity means at 2 seconds, at in between the 2 seconds, the uniform velocity is 50 meter per second. So I will note down that it is a 50. So the question is, what is the distance traveled by the body? So the distance traveled by the body is area under this curve. So this area is a trapezium. So trapezium means half into 2 parallel lines, BC plus OD. Half into BC plus OD, then the height. So what is this height? This height is a what is it? 50. So very simple. So half into BC into BC plus AD into OG. So this OG we can take that. So area of the trapezium is half into parallel lines distance. Parallel lines means BC and OD distance we have to add up, then multiply with the height. This height is a OG. So simply half into BC is a 2 and AD is a 10 and OG is a 50. 2 then it is a 10 and OG is a 50. Just you multiply that, we get an answer 300 meter. So in this question they are given the sentence. We have to draw the graph. Again I will do some mistake here. It is moving the acceleration only. So the acceleration not mentioned here. So it is moving with a certain acceleration of 10 meter per second square. Okay. Yes, students, copy this. So they are given in the sentence. The sentence can be transformed into graph. From the graph, the distance calculated. So very interesting problem. So read the question carefully, understand the concept clearly. Then you have to draw the graph correct. Then from the correct graph, you have to calculate the area or the distance traveled by the body. Now we are going to see that next problem. A train moves from one station to another in 2 hours. So its speed time graph is shown below. This is a speed time graph. So from one station to another station, it takes the time 2 hours. So that is the graph represents. So what is the question? Determine the maximum acceleration during the journey. So initially the acceleration increases slowly and a steady acceleration, maximum acceleration, that is here it is a maximum point, maximum acceleration. So in order to calculate the maximum acceleration, the part BC is a maximum slope. So we can find that this is a maximum acceleration. So the acceleration is maximum during the interval BC. How we can calculate the acceleration in speed and time? That means it is a velocity time graph. Simply area under the curve. So the area under this curve, maximum acceleration, sorry, not a area, it is a slope. If you calculate that, we can calculate the acceleration, because the acceleration is equal to velocity by time. Velocity is here, it is given as a speed, and time is here. So the slope represents the acceleration in velocity time graph. Here it will be represented as a speed. So don't confuse students, here it is a velocity only, not a speed. So in graph they are represented as a speed, but we have to take as a velocity. You may ask one question, sir, how the speed is equal to velocity? In this question they are asked you to draw the speed time graph, but you have to calculate acceleration, means take the speed as a velocity. The motion is in the straight line, means both the velocity and speed are equal. So don't confuse students, velocity and speed never become equal, but one position the velocity and time become speed become equal. That means if the motion of the body in straight line, the distance covered by the body and the displacement of the body both are equal in equal interval of time. That's why it is shown here. So the maximum acceleration is equal to slope of BC. So the slope of BC, this is the BC. Slope of BC is y-axis. So the y-axis is 50 minus 20. What is 50? The maximum height is 50. This is a 20. So the slope BC means this is a slope. Y-axis, x-axis. Y-axis is 50 minus 20. Maximum point 50 and the minimum point is 20. So this distance is 50 minus 20. Then what is this time interval? 0.5 and 10. So don't subtract 0.5 minus 1, because the time never becomes negative. So 1 minus 1.5. So 1 minus 0.5 we get 0.25. So by calculating we get the answer 120 kilometer per hour squared. So hour squared means it is an acceleration. So we have to substitute time squared. The next question is also calculate the distance covered during the time interval of 0.5 to 1 hour. So what is the distance covered in between these two things? So the distance means we have to calculate area. So very simple. If you want to calculate the acceleration, slope. If you want to calculate the distance or displacement, we have to calculate the area under curve. This is the area under the curve from the hours 0.75 to 1 hour. So 0.75 to 1 hour is this one, this one, this one. This shaded portion is we have to calculate the area under this curve. This shaded portion represents the trapezium. So two parallel lines. So half into BE plus CF into EF. So half into BE plus CF. Two parallel lines we have to add and multiply with the height. So height is a 0.25. So very simple. Half into base 20 plus 50. BE means what is a B? Here it is a B. This is a E. So that is a 20 height. Then CF means The height is a 50. Then what is this distance? EF. EF is a distance between them, that is a 0.25. 1 minus 0.75. Very clearly it is given. Okay students, next we are going to see that very interesting problem. This graph represents a velocity time graph. You have to draw the acceleration time graph for this given question velocity time graph. You have to calculate the acceleration for the distance time interval 0 to 2.5. Then we have to calculate the acceleration between the time interval 2.5 to 5. Then you have to calculate the acceleration from the time interval 5 to 7. By seeing the graph itself, the acceleration between the 2.5 to 5 is a 0 because the slope is 0. So then if you calculate the slope of OA and the slope of BC, means that will represent the acceleration in this part. So in time 0 to 2.5, in time 0 to 2.5, OA slope, the slope of OA is 20 by 2.5. So slope of the OA is 20 by 2.5 means y-axis, x-axis. Y-axis is 20 and x-axis is 2.5. So 20 by 2.5 we get 8 meter per second squared is an acceleration. Then in the time interval 2.5 to 5, there is no change in the slope. There is a slope is 0. So acceleration is 0. Then in time interval 5 to 7, the slope is decreasing slope. Slope is decreasing y by x. What is the y here? 20 and the x is 5 minus 7. So we have to substitute that. So 0 minus 20. Why is that 0 minus 20? This is a 0 and this is a 20. So the slope is decreasing. Final position minus initial position. Final position is a 0 and initial velocity is 20. So 0 minus 20 divided by 7 by 5. Never the time become negative. So 7 minus 5. Again I will say that the slope means the distance of y. Here the slope is a BC, the decreasing acceleration. Decreasing acceleration means velocity also decreasing. The initial position, starting position of the velocity is 20 and the final position of the velocity is 0. So 20 minus 0, we never put that. Final velocity minus initial velocity, only the change in velocity. So the final velocity minus initial velocity, only the change in velocity. So you get minus acceleration, minus 10 meter per second square. So very simple. This is a 8 meter. This is a 8 meter per second square. This is a minus 10 meter per second square. So 8 meter per second square acceleration time, and this is a negative acceleration, positive 8 meter per second square from the 0 to A. And for A to B, it is a 0 acceleration. For B to C, negative acceleration. You draw this line and you draw this line just to connect. These are all the things. So this graph represents the velocity time graph of this one. So velocity time graph will be rewrite as a acceleration time graph like this. So this type of the questions only asked in examinations. Now we are completed the graph representations of the different motion of the body, and also the problems also we are solved clearly. So I will show you in order to write the classwork note for this session. So we have started this session with the problem 2. Then this one. Then we moving to problem number 3. From the question we are drawn the graph. From the graph we are calculating the distance traveled by the body. Again problem 4. So I will show you again clearly. I think it is more visible to you. Yes. First page. Second page. Third page. Fourth page. Then we continue the fourth question in the next page. Here the graph. From this graph we find the solution, and we move to the last problem of this video. That means translate this velocity time graph to acceleration time graph. So it is quite interesting to convert. These are all the things, students. So create a interest on yourself and Think yourself, imagine yourself as a practical situation in order to solve these types of problems.